This is Geometry Semester 1. It's the 5th unit called Pythagorean Theorem. It's the 6th lesson called Distance Formula Practice. It's on CreatorMath.com under the Geometry tab. When you Google CreatorMath.com, you might have to Google CreatorMath.weebly.com. The instructions are copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from CreatorMath.com. So I usually try to model for you finding those notes. Let's see if I can pull that off here in a reasonable manner. So here's the website, creatormath.weebly.com. Go there. You should be able to Google it, and hopefully you can get to the home page. Looks like this. Once you're on the home page, we do a composition book in class. All of the requirements of the composition book are on this home page below my picture. Go down to where you see the large print, composition book, the picture of the composition book. Watch all those videos, follow all of these deadlines, and follow all of these instructions of how to put things where, and you should have a 90 to 100% on your comp book. Let's go over to geometry. This is the... we start out with vocabulary. If you're not getting 100% on your vocabulary, you may not know. There's a vocabulary geometry practice study PDF with every word from the entire year on it, and it's searchable. Just Google, how do I search a PDF? Open that up, save it to your computer. Let's go find the right semester for the table of contents. There it is. Sometimes it goes fast. Let's see. So this particular lesson is from semester 1. This is table of contents. This should have all been written on pages 2 through 6 of your composition book. If you haven't done it already, stop what you're doing now and please do it. Let's find the 5th unit. That's number 3, number 4. There it is, number 5. Pythagorean Theorem. And we are in the 6th lesson. So if you look, 1, 2, 3, 4, 5, 6. This is the last lesson of Pythagorean Theorem, distance formula. Here are the page numbers that these notes go on in your comp book. Don't look at this video to find the pages. Look at the original table of contents at the time you're viewing this. By the time you view this, these page numbers will most likely be different. Here's how you find the notes. Open up this Notes tab. Click on it. Fair warning, it takes me a couple times sometimes to open it. There it goes. I saw it. You're going to copy these notes onto those pages in your comp book, and these are going to help you do the problem set that I'm about to do now on this video. So distance formula is nothing more than the Pythagorean theorem solved for the hypotenuse, right? So distance formula is, here's the Pythagorean theorem, height squared equals leg squared plus leg squared, and you might have learned a squared plus b squared equals c squared. I'm going to try to retrain you to use the height squared equals leg squared plus leg squared. For me, it gives students a lot more chance at success because they have a hard time figuring out where the legs of the triangle go and where the hypotenuse goes in the a squared plus b squared equals c squared. So we just take the square root of both sides, and this is the distance formula. The legs are found by just subtracting the y2 minus y1, we square it, and x2 minus x1. So this will go in your notes, and we're going to apply this in these problems. Here's a setup of solving this thing. Here's how these, the y direction takes care of one of the legs and the x direction takes care of the other leg, and how that fits into the Pythagorean theorem. That's why the distance formula is in the Pythagorean theorem unit. So here's a Pythagorean theorem solved for the hypotenuse, then plugged in where we did y2 minus y1. We're going to do a few of those in the problem sets. Here's the vocabulary. You got to know which sides are which in the triangle. You got to know how to find the hypotenuse, which is the longest side of the triangle, and the side across from the largest angle. In a right triangle, that would be across from the 90 degrees. It's across meaning not touching. I'll abbreviate it hype for hypotenuse, and then where the legs are the two sides attached to the 90-degree angle. So with that, let's take a look at some of the problems and solve these and see if we can illuminate what we're talking about. So first things first. What's the Pythagorean theorem? Height squared equals leg squared plus leg squared. And like I said, a lot of students learn a squared plus b squared equals c squared. The problem is they don't know what to plug in for each of these. So I say, why even bother using a, b, and c when you can just spell it out? You can say height squared equals leg squared plus leg squared. And I like to focus, because students get mixed up on legs, they're like, which goes in which place, right? So, I always say, well, 3 plus 5 is the same as 5 plus 3. These are both 8. right? So you don't need to care which leg goes where because you can put them in either position and they're going to add up the same way every time. Then I like to reverse it and say hype squared equals leg squared plus leg squared to focus students on that hypotenuse first. To me, that's the trouble side of the triangle to deal with first, so this is it right here. Hype squared equals leg squared plus leg squared. That is the Pythagorean theorem. And if I could have you use that instead of a squared plus b squared, I'd love it. What's the hypotenuse? So here's a right triangle. Hypotenuse is the longest side, the side across from the largest angle, therefore not touching the 90. That makes this a leg, and I always try to say something cute like a triangle has two legs like a human, right? Trying to get students to remember that 2 of the 3 sides of a triangle are legs. And this one is the hype over here, hypotenuse, hype. So longest side across from the largest angle, which is 90 degrees in this case. And the side not touching the 90. We got 3 correct answers here. The side at the bottom, no. The shortest side, no. The side across from the smallest angle, no. These 3 are correct answers, and it does say more than one answer may apply. This is the 6th lesson of this unit, by the way, so I'm trying to go a little bit quick here. If you want to know more, go back to those first lessons on the Pythagorean theorem. All right, what is the leg? What is the leg in a right triangle? Either of the 2 sides touching the right angle. So there it is here. We already drew it. Leg, leg. Either side touching that 90-degree angle. Name the sides. These are touching the 90, so this is a leg, and this is a leg. A triangle has 2 legs like a human. That makes this by default the hype, but we can also see it's the longest side and the side not touching the 90. Or across from the largest angle. So A is a leg, C is a leg, and B is a hypotenuse. Name the side. So this is a Cartesian coordinate plane. You can see here 0, 0, the origin. This went out 9 on the x and 0 on the y, so it's right to the right. This one went out 0 on the x and 5 on the y, so it went straight up 5. Here's your triangle. That makes this the 90. So this got to be a leg because it's touching the 90. This got to be a leg because it's touching the 90. The one not touching the 90 is the hype. Right? So A is a leg, C is a leg, and B is the hype, or hypotenuse. Now they're going to move us into the distance formula. What is the distance between point A and B? More than one answer may apply. So it looks like all we have to do is set up our problem here. So notice we're given a right triangle. Here's the 90. This is the hypotenuse. So we want to use the Pythagorean theorem, right? We want to use height squared equals leg squared plus leg squared. We want to take the square root of both sides, here and here. And how do we calculate these legs? We do y2 minus y1 for this one, and we do x2 minus x1 for this one. That'll give us the distance here of each of these legs. We can count them too. We can go 1, 2, 3, right? But we're going to use the full formula here. So height equals square root of, let's go with y2 minus y1. So let's make this y2 and this y1. So we're going to go 2 minus a minus 1. 2 minus a minus 1. That's squared. We are adding them. Let's do the x's now. So if this was y2, then this has got to be x2. So we're going to go 4 minus a minus 2. 4 minus a minus 2 squared. Remember, there's a minus in the formula. That's where the first minus comes from. Remember that if there's a negative on the number, that's where the second minus comes from. I use the word minus and negative interchangeably. For me, they operate the same way, so other teachers may tell you not to do that, but I do that, right? And I'm going to continue to unless something big comes up. So let's just check. What have we got here? So it looks like we have an x2 minus x1 and a y2 minus y1. These are squared, and it's a square root of. So this is the generic. That's what we started with here. Then it looks like we have 2 minus a minus 1. 2 minus a minus 1 squared. And we have a 4 minus a minus 2. So this one's correct too. It's filled in. looks like they're going further. Interesting. All right, so this equals square root of. This is minus minus is plus, so 2 plus 1 is 3 squared. Minus minus is plus, so 4 plus 2 is 6 squared, so plus 6 squared. So look at this, 3 squared and 6 squared. They're taking us at each step, they're going on down. So all three of these are right so far. Wow, looks like we are continuing here. Square root of 9 plus 36, that's right here. Adam, you do get 45. That's going to be right. And it looks like they're simplifying 45. So let's get down to there. Let's say height equals square root of 45. So what we have here is what perfect square is in there. It's 9 times 5. So square root of 9 times 5 is 45. The 9 is a perfect square, so it comes out as a 3. And the square root of 5 stays under. So 3 square root of 5, this one here. It's all of these except this last one. All right, so 1, 2, 3, 4, 5, 6 answers that are all correct for this. Whoops, I'm sorry. So this is square root of 45, which is 9 times 5. And because the square root of 9 is a perfect square, it comes out as a 3, and the 5 stays under. So 3 times the square root of 5. All right. Sorry about that, you guys. I get carried away, and then I'm not showing you what I'm trying to show you. All right, what's the distance? Looks like the same drill. So let's start out with height equals square root of y2 minus y1 squared plus x2 minus x1 squared. Do they give us that? Yes. I see how this is working now, so this one I can go a little bit faster on. There we go. All right, let's go to the next step and see if that answer's there too. So let's just pick. It doesn't matter what you pick. All right. If this becomes y2, this minus 4, square root of minus 4 minus 2 squared plus, and if this was y2, then this has to be x2. So 4 minus a minus 1 squared. Okay, so do we have, now notice that this is here and this is here, but remember, you can add 3 plus 5 or 5 plus 3, you're going to get the same thing. So it's okay that I did mine here and they did theirs second. So minus 4 minus 2 squared, that's a check, right? And 4 minus a minus 1, that's a check. This is good too. Let's do the next line. Negative 6 squared, because negative 4 minus 2 takes you to negative 6. 4 minus a minus becomes plus, so this becomes 5 squared. So how about a minus 6 squared and a 5 squared? Good. Let's do it again. Negative times negative is a positive, so this becomes a positive 36 plus 25. Good. Okay. 36 and 25 is 50, 61. Good. What perfect square is buried in this? Is there a 9 in this? 9 times 5 is 45. 9 times 8 is 72. I don't see any perfect squares buried in 61. I think we're done here. This, I think, is no, and this is no. So 1, 2, 3, 4, 5 correct answers on this one. All right, let's do it again. This one's interesting. No triangle formed, you guys, but we can still do y1 minus y2 and y2 minus y1. y2 minus y1 and x2 minus x1. Let's write it out. Sorry, I'm butchering this. Square root of y2 minus y1 squared plus x2 minus x1 squared. So we have this one, the generic. Now let's fill it in. Height equals. All right. So what do you want to call? You want to call this y2? Doesn't matter. You can call that y2. Doesn't matter. Just be consistent. If we call this y2, then this becomes y1. So negative 4 minus 2. Square that sucker. Keep the square root over the whole thing. Okay, now let's do the x's. If this was y2, then this has to be x2. So 4 minus 4 squared. Height now equals. All right, so we got this one. Minus 4 minus 2 is minus 6 squared. Plus, look at this. 4 minus 4 is what? 0. Well, 0 squared is 0. Okay, do they give us a 0? Yes, they do. They give us a 0 plus 36. That's going to be the next line for, here we go, hype. 36 plus 0. We're just going to do radical 36 because that's all 0. What is the square root of 36? It is 6. Remember in the old days in algebra you'd have plus minus here? We don't have a minus because it's a physical distance. There is no negative physical distance, right? Negative is a direction, not a distance. So all the way down here and here. This is out. This is out. Now, let's just check. It says the distance is 6. Is that right? Start here. 1, 2, 3, 4, 5, 6. Look at that. Okay, so very interesting. All right, this is easy for us to count. I was just looking back at this one just to show you, I'm counting up the distance. Why can you not just count here? Come on, focus. There you go. Look, how do you count? I mean, did I go 1 here? No, it's part of 1, right? Did I go 1 here? No. No, so I can't really count this one at an angle. This one I can count because it's right along with our grid, and therefore it's easy for me to go 1, 2, 3, 4, 5, 6 and confirm that I got the right answer there. In fact, I don't need the distance formula with this because I could count it physically. But with this one, I definitely need it. I cannot count that distance square root of 61 physically. All right, what's the distance between? What is the distance between point A and point B? More than one answer may apply. So we can count this one. 1, 2, 3, 4, 5, 6, 7, 8. So we know it's 8. It's not going to be negative 8. It's not going to be this. So we already know this. Let's go ahead and hype equals square root of y2 minus y1 squared. By the way, can this be x2 minus x1? Of course. Remember, you can reverse 3 plus 5 or 5 plus 3 and still get the same answer. Plus, that'll make this y2 minus y1. Let's reverse it for this. All right, pick, what do you want for y? What do you want for y2 here? I mean, I always go with, I guess, I'm biased, but it doesn't matter. 1 minus 1. Notice that's going to be 0 and be gone. Okay. If this is y2 here, then this has to be x2. So 6 minus a minus 2. 6 minus a minus 2. This is plus, so 8 squared is 64, and this is 0, so plus 0. Hype equals square root of 64, which hype equals 8. All right, so we have square root of 64, 0 plus 64. I'm going backwards now up through the list, and the generic. These are all right. You see the pattern of the way this is going. All right, let's keep going. We can't count this one because it's at an angle. So we definitely need the distance formula for this. Square root of y2 minus y1 squared plus x2 minus x1 squared. Hype equals y2 minus y1 is, make this y2, doesn't matter which, negative 1 minus a minus 2. Negative 1 minus a minus 2. A lot of negatives, but don't panic, just put them in. We'll sort it out on the next step. If this was y2, then this would be x2. So 6 minus a minus 2. 6 minus a minus 2. Okay, squared. Height equals, so this is plus, because 2 minuses is a plus. A 2 minus 1 is 1, so 1 squared. This is plus, so 8. 8 squared. Don't forget the square root over top. Height equals 1 plus 64. Height equals square root of 65. I don't see any perfect squares buried in there, right? So square root of 65, these are all correct all the way up. I'm speeding through it a little bit because they're all repetitive at this point. But that's the main one here in the bottom. No, it's not, that'd be 64 there if it was 8, right? So it's not 8. All right. What's the distance? Okay, repeat. Height equals square root of y2 minus y1 squared plus x2 minus x1 squared. Height equals, if this is y2, it's a negative 4 minus 4. Negative 4 minus 4. It's squared. We add to it. If that's y2, this must be x2. Negative 1 minus a minus 4. Negative 1 minus a minus 4 squared. Hype equals square root of. So negative 4 minus a 4 is minus 8. And that's going to be squared. This becomes 2 negatives, so it's a plus. 4 minus 1 is 3 squared. Hype equals, it's going to be negative 8 times negative 8 is 64 plus 9. Hype equals 64 and 9 is 73. I don't see any perfect squares in 73, so I'm going to go with this one, this one, this one, this one, and this one, all the way up. All right, all the way up through that chain there. And you can freeze the video here if you need to go back and see any one of these. Looks like they're doing it again. How many more pages they got for me? y2 minus y1 squared plus x2 minus x1 squared. Hype. I can't seem to write hype. Equals 1 minus 3. If this was y2, then this has to be x2. 7 minus a minus 3. Now just clean this sucker up a little. 1 minus 3 is negative 2 squared. This becomes plus, and so therefore 10 squared. This becomes 4 because negative 2 times negative 2 plus 100. So hype equals square root of 104. I don't think there's any perfect squares in there. Look at this, 26. What's that? 26 times 4. So this is equal to, I'm looking at the answer and cheating a little bit. 4 times 26 in here is 104. I get it. This is a perfect square, so it comes out as 2 square root of 26. So it's this one and all the ones above it. One more. Boy, they're really making me work on this one. More than one answer may apply. Can I even see this? Let's go up to here. Hype equals y2 minus y1. We're going to square it plus x2 minus x1, and we're going to square that. And there's square root of the whole thing because we need just the hype over here. So if this were y2, negative 4 minus 2. If this is y2, then this is x2. 4 minus a minus 1. Negative 6 squared. Put a parentheses to make sure the negative is included in there. Plus, so this is 5 squared, and a plus here. Negative times negative is positive, so 36 plus 25. 50, this is 61 again. Square root of 61 looks like. So here we go. All right, make sure you're matching up the titles so that you're matching the actual practice you're doing with the video you're watching. This is Geometry Semester 1. It's the 5th unit called Pythagorean Theorem and the 6th lesson called Distance Formula Practice on CreatorMathcom under the Geometry tab. Hope this helps.